see, it looks like we had another word type problem. See, James biked 5 miles in 20 minutes. 5 miles, 20 minutes. And 6 miles in 30. All right, I'm seeing ordered pairs here. Write a linear model to model the distance James runs, I should say bikes, d in t minutes. So d equals t minutes. How far could James bike in 60 minutes? Okay. Let's see here. Basically, they've given us 2 points. We got to figure out which one's x and y. Since they want us to calculate distance, okay, we'll call that our y. And since they want it in terms of time, we'll call that our x. So here's our ordered pair. So we've got 25. There's our time, first, and distance. And we've got 30 and 6. Let's figure out a slope. Just doing y2 minus y1 over x2 minus x1 here. So 6 minus 5 over 30 minus 20. 1 over 10. So that's 0.1. And so right away, if we look at these, there's 2 that have 0.1 in here. Only one of these, though, is calculating distance. It's this guy here. Oops, here's another one that does that. So it could be this guy as well. Okay, distance equals 0.1, and that is our slope. 1/10 is 0.1, 1/10. Let's go ahead and find that full equation. So we go y minus y1. I'm going to slide up here. Oops, not quite that way. I'll slide up like this. So y minus y1 equals m times x minus x1. Now we got 2 points that it goes through. You can use either of these 2 points. I'm going to use 20 and 5. So y minus 5, that's the y value, equals slope point m, x minus 20. Y minus 5 equals 0.1x. A tenth of 20 is just 2. So 0.1x, add your 5 to both sides, plus 3. And so now we can make a decision. If we look at our choices here, I know that it is this guy, this first one here. 0.1t plus 3. And apparently he goes 10.5 miles if he uses 75 minutes. Now we'd have to be really careful here. Yeah, this thing was all derived from time units of minutes, so we're all right. So let's find out y. Oops, let's keep it up here with the problem. So y equals 0.1, type in a 75, or substitute in 75, plus 3. That's 7.5 plus 3, that is 10.5 miles right there. Not too bad. All right, problem number 21. Give ourselves an absolute value problem. Here's how we solved them. We said, hey, get it so you have the distance part of it, the absolute value all alone on the left of the equation. Then read it in terms of distance. The distance from 0 is -8 units. Now you have to be careful here. When we measure distance, everybody, distance is always positive. In fact, the absolute value always gives you a positive number because it's telling you a distance. So when is the absolute value of something equal to -8? Never. And so once we realize that, we can just put no solutions to it. Absolute values can never result in a negative number. Doesn't mean you can't have a negative number inside here. Like this could all end up equaling an 8, but then the absolute value of 8 is not -8. And if all this stuff in here equal to -8, that's fine. But the absolute value of -8 is not -8. It's just 8. So no solutions work for that problem. Okay, problem 22. Get ourselves another absolute value, but this time it's got an inequality in it. That's no big deal. Okay, let's just get that absolute value alone again. We'll add 4 to both sides, giving us 2. X plus 3 is less than or equal to 12. Absolute value is not alone yet. It's 2 times the absolute value, so we'll divide away the 2. There we go. Now our distance is 6 or less than 6 units away from 0. So if this is 0, this is 6, and this is negative 6. That means we're getting closer and closer. It means we got to be greater than a negative 6, but less than a 6. They got to be bigger, like negative 5, negative 4, negative 3, negative 2, and less than 6. So we write two equations. This is what allows us to get it out of the absolute values. We say, hey, x plus 3, you have to be less than 6 because you got to be getting closer, 5, 4, 3, 2, 1 this way. At the same time, though, x plus 3 has to be greater than negative 6 so that we're getting closer and closer to the 0 in that direction. So those are two inequalities. And what we said is, hey, just drop the absolute values, write it the way you see it. X plus 3 less than 6. X plus 3 less than or equal to 6. Then write it again without the absolute values, but flip the inequality, less than went to greater than, change the sign, negative 6. Let's go ahead and solve these two and get the answers. Subtract 3, so x has to be less than or equal to 3. Subtract 3, x has to be greater than or equal to. Negative 6 minus 3 is negative 9. So x must be less than or equal to a 3, and at the same time greater than or equal to a negative 9, which means x must be somewhere in between those two numbers. And so here's how we write it. X is in between those. Notice the x is bigger than negative 9, so we point left. X is less than 3, so we point left. And we can see one of our answer right over here. There it is. Negative 9 is less than or equal to x is less than 3. Solve those two inequalities and you got it set. 23 is the same thing. Okay, absolute value, inequality. Get the absolute value alone. So here we divide by 3. Hey, look at that. When is the absolute value of something greater than negative 4? The answer to this is always, remember, absolute values give us positive numbers out or just 0, but you never get negatives out. And so no matter what x is, x is negative a million, fine. When I absolute value it, the answer is going to be whatever negative a million minus 5 is, negative a million and 5. Okay? And that would be just the absolute value of it, a positive million and 5. So no matter what you plug in for x, you always get a positive number, and therefore any x will do, and therefore we answer all real numbers will work. Notice this would be way different. Had this been, when is it less than negative 4? In that case, we'd say never, because again, only positive numbers come out, and no positive number is less than negative 4. So this would be no solutions. Let's see here. Find the value of f of negative 5. We've done this so many times now, everybody. We did it all day long when we were finding vertices. We talked about how you can use your calculator for it, and we talked about how you can do it by hand. I'll do this by hand, of course. So you have to square first. So it becomes 4 times 25. Remember, when you square a negative, it's always a positive number. And we multiply, that's 100. We multiply, that's negative 15 minus 2. 100 minus 15 is 85 minus 2, and 85 minus 2 is 83. So the f of 5, or negative 5, is 83. All right. From number 25, if I can get things going here. Find the slope between, shrink it down just a little bit, the right tool here for it. There we go. Find the slope between those 2 points. Just remember your slope equation. y2 minus y1, x2 minus x1. Always y's on top, rice is overrun. Just label these to keep track of them. y2 is 12 minus y1 is negative 8. We're getting double negative. x2 is 3 minus x1 is 3. Ruh-roh. On the top, the double negatives cause us to get a 20. On the denominator, 3 minus 3 is 0. You cannot divide by 0. That is undefined. Don't forget, undefined. That means this is a vertical line at 3. There's x equals 3. Just like all those axis asymmetries were. Number 16, 26 rather, find the solution to this system. There it is. This is equation 1. This is equation 2. Where do they cross? Right there. Remember, solutions to systems are where they intersect. Here's 0, there's 5. This is 6. 1, 2, 3. So the solution, 6, 3. We had a problem on a quiz where we had a circle like this was one of our graphs. We said, hey, what are the answers? Well, right here would be an answer. If there was 2 lines on there, this would be an answer. Any place that 2 graphs intersect. Now, if this was a system of 3 equations, equation 1, equation 2, and the circle was 3, this system itself has none because there's no point where all 3 of them cross. Okay. If we just consider the purple and the red as a system, they have a solution here and a solution there. Let's see here. Oh, so there's our answer, 6, 3b down here. And then problem 27, solve this by any method. Let's see here. I think I could divide this all by 2 and make it smaller, but still nothing would really line up and eliminate. I think I'll just take this equation times a 4, negative 4, because that'll give me a negative 8. So the first equation I'm going to leave, 8x minus 2y equals 12. I'll take the second equation times negative 4 to give me a negative 8x. See, a negative 12y and a negative 12. I add those up. Negative 14y equals 0. Just fine. Divide by negative 14. I can divide into 0. There's no 14s in 0. Now I just take my y value and I'm going to run it up to equation 1 and put a y of 0 in. 8x equals 12. So x equals 12 over 8. Both divisible by 4. So these 2 lines intersect when x is 3 over 2, or 1.5, and y is 0. Pretty easy, I think. Let me double check that in the other equation. If I plug in y is 0 there, x would be 3 over 2. Yep, so it works. So that was a quick page. Problem 28, check whether the ordered pair is a solution to the system. I was just checking on that last one. We just substitute in right here and find out if when I plug in 8, 5, does it give me 1? When I plug in 8, 5, does it give me 30? It's got to make them both true. So we've got 2 times 8 minus 3 times 5. That's 20, oops, that's 16. Minus 15, that equals 1, so that checks. The other equation, 5 times 8 plus, oh, that's supposed to be a y. I'm certain of it. 2 times 5. That's 40 plus 10, so 50. So no is the answer to that one. Problem 29 here, solve the system any way you want to. Since this first equation is solved for y, I'm going to use substitution. So here's the second equation, negative x plus. I replace the y with negative x minus 5, and then that equals 9. So it's just this equation with the y replaced. Okay, so now I clean up the side, that's negative 2x minus 5 equals 9. I add 5 to both sides and divide by 2, so x is negative 7. Now I just take that negative 7 up there, that's y equals negative 7 minus 5, or 7 minus 5. Y equals 2, so there's my solutions, negative 7, 2. And I crammed that last one in there. But our solution, negative 7 and 2 here. I know the -7 works in there because I used that one, so I'm going to check it in this one. If x is -7, that'd be a +7. Y would be a 2, and +7 plus 2 is 9. So it does check. So we're in good shape there. Let's look at number 30 here. Get it all in for you. There we go. A car company charges $50 flat fee and $3.25 per day for rental. So charges, see, cost, that's the same thing as charges for D days. So flat fee, their slope, $3.25 per day. So charges is 3.25 times days. So it's like dollars per day. When you take it times days, the days cancel, just giving you dollars. Hopefully that tracks for you. But I think it gets cluttered sometimes when we put all those in there. So it's just 325D, and then plus this $50 flat fee. So that's one of the equations. The other company charges $30 flat fee and $4 per day. So their equation would be C equals 4D plus the $30 flat fee. And then it says find the number of days for which the costs are the same. Let's see what they've given us for answers here. So 3.25D plus 50 equals C. That's this first equation. 4D plus 30 equals C. That's the second one. So looks like nobody else matches that one. So it's got to be answer A here. But let's go ahead and solve it. This one I'd solve by substitution. See how they both equal C? So we can just set them equal to each other. We can say, hey, 4D plus 30, you have to equal C, and so does the other one, so therefore you equal each other. And now we'll solve this guy. We'll get our subtract our 3.25 d's from both sides, giving us 0.75d equals, subtract this 30, equals 20. So now I just have to divide by 0.75 on each side of my equation. 0.75. Let's see here, 20 divided by 0.75. I should just do that in my head. But I'm getting about $26, or these are days I'm calculating, 26.6 days, so 27 days. And so it does match with A all the way around. And 31, solve this system. Now, you guys know how long solving this systems take, but this thing's multiple choice. So we can also solve or check these solutions. Now, as you check them, you can maybe check these easy ones first. Like if I plug in 0, 0, does my z value, remember this is x, y, z, come out to -2.4. So I'll go 0 times 4 here is 0, or 4 times 0, 2 times 0, -2 times 0, whatever. Those two would just disappear because of these two zeros. So -3z equals 8 would be the result. So z equals -8/3. See, that's 2.6 something, -2. It doesn't give you 2.4. You try it on your calculator, you'll see it's 2.6 repeating, or -2.6. So these solutions don't work in equation 1, so we know it can't be a solution to the system. It has to make all of them true. So as soon as one of them fails, you can just cross out that answer. So I would do the same thing then with this other double zero one and say, hey, if I put a 0 and a 0 in, does -3z, is z a -1? And clearly it's not. So now I'm down to 2. I'll test the first one because it has a 0 in it. See, 4 times 1 minus 2 times -2 minus 3 times 0. Does that give me the 8? It's 4 plus 4 plus 0. That's 8. 8 equals 8. So it did check in the first one. Now, since that first point checks in equation 1, I'm going to check it in equation 2. So it'd be 5 times 1 plus 3 times negative 2 minus 4 times 0. Does that equal 4? See, that'd be 5 minus 6 plus 0. No, that's a negative 1. That doesn't equal 4. So it can't be this one. So it's got to be equation 2, or answer 2b there, rather. Let's check it, though. Does it work in the first equation? 12 plus 2 minus 6. That's a 14 minus 6, which is 8. So it checks in the first equation. I'll check it in the second equation. It would be 5 times 3 plus 3 times negative 1 minus 4 times 2. Just checking this x, y, and z again. 15 minus 3 minus 8, that's 12 minus 8, that's 4. Checks in the second one. Feeling pretty good about it now. And of course, you can do a lot of this on your calculator. You'd have to write it down like this. Then stick it into your calculator, see if it gives you a 12 out. In this case, it's 18 plus 4 minus 10. It's 22 minus 10, that's 12. It checks in the third one. So I know that's my answer, B. Now the other way you go about solving this, remember, is you combine two equations, eliminate a variable, then combine a different two and eliminate the same variable. Very tough problem if you're going to crank that thing out by hand, because none of these match, none of these match, and none of those match. I think I'd probably, gosh, I don't know, I'd probably go with this column. Use these two, using a 6 to get rid of both those, and the first and the last using a 4 to get rid of those. Either way, it'd take you quite a bit of time. 32, use vertex form to write the equation of the parabola shown at the right. So let's find this vertex. This vertex is at 5, 2. In vertex form, a times x minus h squared plus k. That's your h, that's your k, so it's a times x minus 5 plus 2. Now we don't know the a value per se, but if we look at it, this thing's going by ones here. So this goes over 1, up 1, over 2, up 1, 2, 3, 4. So this is the same shape as our parent function. So a must be just a 1. It didn't get stretched or anything. So x minus 5 plus 2. Answer C. Now our last page, 33, what qualities are true here? The zeros and the x-intercepts are the same. That's true if you think about a parabola. Okay. These are where it equals 0. That's your y. Where's y 0? Right here at the x-intercept. P 0 and Q 0. Okay, so that's true. A is. The axis symmetry always passes through the vertex. That's absolutely true. That's the one point on a parabola that is not symmetric. Didn't have a matching point, so that's true. It's symmetric about the axis of symmetry. Yeah, that's the whole point, that these 2 points here, they match across from each other. It's symmetric about that axis. So that's true. Its domain is all real numbers. That just means what x values can you plug in. You can put any x value in. It's the y values that get limited with a max or min. It has a max or a minimum. That is true. Either has a highest or a lowest. So all those things are true about a parabola. 13. Find the vertex of the parabola modeled by that equation. His vertex is, let's see, h is 5 and k is 3, so 5, 3. We're just using comparison to the parent function or the vertex form. And so we'd see our h here is just the 5 and k is just the 3. And our last one, identify the axis of symmetry. Remember, the axis goes right through the vertex, the lowest point. This is at 5, 2. So it's x equals the x value, so x equals 5. And that's it for your test review. Not too bad.